Hi everyone, thank you for staying with me. So I'm going to present an approach about how to test concurrent workflows by combining two techniques. The first is form methods, and the second is model-driven development, or MDD for short. I'm going to actually also give you some case study at the end, just to give you intuition. And for the details, I encourage you to read my paper. So the problem domain of this approach is that of information systems. In the information systems, we have large amounts of business data. And interestingly, sometimes the data itself is even more important than the system itself, because we want to maintain the meaning or the semantics of our data. And usually, we document or we capture the semantics or the semantic meanings of our data by two things. First is the entity associations, and the second is the integrity constraints, reflecting two things. First, we want to tell the users, or we want developers to tell the future users what should be the intended interpretation for your model. And the second thing is what should be the patterns of usage for your operations or model operations, or even workflows. Let's have a look at one example very quickly, just to show you what I mean. So let's say we have a very familiar object model. So let's say we're talking about a hotel reservation system. So we have a class called hotel, and it has, let's say we have an attribute called reservations. And the intended interpretation for this attribute is we want to store the set of reservations of this hotel in this attribute. So that's the intended interpretation. And what should be the pattern of usage? We declare some entity association. So this is to say, we have an association between the hotel and the reservation class. This is to say, in the hotel class, we have an attribute called reservations. Symmetrically, in the reservation class, we have an attribute called host. So this reservation object should be one of the reservations in the hotel, and hotel must be that reservation's host. So we have a by association between. And what about integrity constraints? We can document it in invariance constraint. This is to say, at any time of the system, we must have the number of allocations smaller than or equal to the number of rows available to us. That's quite obvious. So that's what I meant in the beginning. So let me just go back. Right. So that's about the semantics of our data. So now, what's really important is if we have any violation to our semantics during the operations, then later queries to the system will return some inconsistent results. For example, let's say I store an age attribute in my person class, but if I do anything wrong with my updates, maybe you ask me, oh, what's the age of Jackie? And you return, oh, he's -1 year old, which is inconsistent, of course. That's a very simple example to demonstrate. And one very important feature of the information system is operations typically represent simple data transformations rather than complex algorithms. So that's why the model-driven development methodology can come into the context. Because what's really the key or spirit of model-driven development is you have some abstract model at the top. You want to automatically generate some working code, executable code at the end. And what you want to document and prove for the correctness is the transformation process to make sure it's actually correct. So if you are only doing a simple transformation, the transformation process should be easy to prove. Right, so that's why the model-driven development can come into the context. Now, so updates, we have two kinds of updates. So one is about individual operations, and we have two things, two components for the operations. One is preconditions, the other is postcondition. So postcondition simply document what should be the effects of your operations. So described as a relation between the before state and after states. And the precondition is about the applicability of your operation. Under what circumstances can your operation be called? And in our context, we are adopting a blocking semantics, which means you're trying to call this operation, but you have to check if this precondition has been satisfied or not. Currently, If it is, okay, go ahead and take the effect by the post condition. Otherwise, you'll be blocked, and you are not able to call the operation. That's a very important feature for the blocking semantics. Now, the question would be, how can we be sure that the precondition for our operations is not too weak or too strong? Because if it's too weak or too strong, then we might be blocking the wrong state. Maybe it's too strong, and then we're blocking unnecessarily the state, or it's too weak, then, yeah, the same, right? The other kind of updates is workflows, because it's usually not so practical to, well, usually workflows have many stages, because you want to collect inputs for the next stage to take place. But it is not so practical to restrict the access from other workflows. For example, let's say I'm trying to reserve a room in a hotel. While the hotel is waiting for me to confirm with the reservation, the hotel must be able to allow you to also book the new room, rather than say, okay, because Jackie is now he hasn't decided yet, so you have to wait until he has decided, he has confirmed. So that's why the workflows is more realistic scenario for our usage, really. So we have a series of interactions for inputs, and the patterns of the operations might be grouped to achieve a specific goal. So let's say we have 100. So each one of you here has a booking workflows. The goal is everyone, if you are allowed to initiate a working workflow instance, you must be able to complete. It shouldn't be the case that, okay, the hotel reservation system allows me to start, but right before I want to confirm that I really want this reservation, they tell you, oh no, there's no space available anymore. That's very important. And the second kind is, let's say we all completed, but we actually want some properties to be established. Let's say after all of us have reserved a room, there must be another 10 rows left. Let's say that's a minimum requirement for the hotel in case of emergency. Right? So that's exactly the scenario I just described. So you want to make sure every time if you do allow a new instance of workflows to be initiated, you got to make sure the existing workflows can still complete. You don't want to have any earlier initiated workflows to get stopped in the middle. And the problem is actually not so trivial, because you might have an arbitrary number of running instances of workflows. And the system integrity or the property that you want to establish when all the workflow complete might be very complex or sophisticated. So what you really want is a systematic way to calculate some kind of precondition for all your workflows to say, okay, before all the workflows can initiate, I want to check this condition first. If this condition is true, then I can guarantee you all the workflows can complete and establish the corresponding properties. Otherwise, we block. We would say, no, you cannot do that because we cannot guarantee anything. Right. By the way, do stop me if you are lost in anywhere. I'm very, very open to discussion in the middle.